Hello everyone, we're going to be doing notes on electricity. So let's set up our page. I'm using a fountain pen just because I thought it would be cool to try. And it's kind of cool, but I also feel like I'm going to cut through my paper, which is weird. Alright, so let's set up our paper. We're talking about electricity. And we're going to put our name up here and the date, which is 3/9. Wait a second. 4/9/21. And our essential question is, what is electricity? Because it's kind of complicated. Yeah. Question mark. All right, so let's break it up into the basic parts. So, parts of an atom. Parts of an atom. And there are three parts that we're going to worry about. There's a proton, there's a neutron, and an electron. Obviously, the most important one for us is this electron. These are their charges. Protons are positively charged, neutrons are neutral, and electrons are negatively charged. So a charge is something important. So we got to make that one of our vocab words. So a charge is dependent on electrons. So it depends on the electron balance. So if I have more electrons, it's going to be negatively charged. If I have more protons, it will be positively charged. If they're equal, then it's neutral. So this one's pretty obvious, but how do I write this? It wants to go towards a negative. Do I need to put them in parentheses? So a positively charged particle is going to be attracted to a negative one, but if I have a positive and a positive, then they'll repel from each other. Or a negative and a negative. Kind of like magnets. When you put a North Pole and a North Pole, they go away from each other. This is basically the same thing. All right, so we talked about static electricity yesterday. Static electricity. So this is an object basically holding these charges. So I'm going to say an object holding a charge. So static electricity. So it's So if they how do I write this? It's basically this. I don't want to write that twice. All right, let's move on. Charge transfer. We can move electrons. Transfer. We can move electrons in 3 different ways. So we're going to go through the 3 different ways. Number 1 is through friction. So when you rub your socks on a carpet, that is going to cause electrons to move from the carpet to your socks, and therefore to you, and then you're going to build up a charge. So this is by rubbing 2 objects together. Causing some electrons, electrons to move from one object to another. So that's friction. Our next one is induction, which is kind of tricky, honestly. So we saw on Bill Nye that they had a balloon, and by putting the balloon on the wall, it actually sticks to the wall by induction. And what that is moving electrons to one part of an object because of a nearby charge. So, for example, if I have a wall, let's just draw a little picture here, and then I have my balloon, let me draw a balloon. Super good, excellent balloon. Let's say this has a bunch of negative charges on it. Well then, this is already going to be a positive, negative, so on. But as it gets closer, it pushes away the negatives so that they're further away. And so there's this charge, this positive charge on this wall, and now a negative charge on the balloon. They're attracted to each other, and that's why the balloon sticks. So there's less negatives because they're pushed away by this other charge. So moving electrons to one part of an object, so they're moving them away based on a nearby charge. So this is that nearby charge. So it's kind of cool. Science, man. Conduction is our last one. Am I holding this wrong? Conduction. So conduction is charging by contact. So this is like, for example, a, shoot, what's it called? Electric fence. Some of you have probably touched that, you know, electric fences. So it doesn't work unless you're actually touching it. Or when we were playing with the Van der Graaf generator, when you put your finger on it, it was constantly moving those electrons to you. And if you stood on that little plastic bucket, you were kind of protected from the ground. And it was cool. So the next stuff is going to deal with lightning and electric discharge and stuff. So we'll do that tomorrow. So we'll stop here and we'll call it good for today. So good luck. Fill this out. Thank you.